So we're going to start in today on Unit 11-12. We'll start by looking at some material at a box A here. We're going to look at intervals of increase and decrease. So what I've done here is I've just drawn some function here, f at x, over some interval here from A to D. And we just want to take a look at where is this function increasing and where it is decreasing. And it's important to keep in mind that we're looking only at small little portions of this curve as we go along here. So here's what we want to look for. A function, f at x, is increasing when, okay, and let's, up here at the top, we'll put the caveat on an interval, and we'll just call this interval I. So basically this is just saying we're only looking at sort of small regions of this curve at any particular point in time. So let's just start by looking, well, if we look at this function here, where is this function increasing? Yeah, between B and C. And between A and B and C and D, what is it doing? Decreasing, right? How can you tell?
It's going down, and then when it hits B, it rises up, and then C after C, the slope goes down.
Yeah, so you can just sort of think of this in terms of where it's going down, where it's going up, and things like that. Now, if we want to make this mathematical, we can say that, let's pick, because we're looking at increasing here, let's pick this interval where it's increasing, and let's take a specific value of x, and we'll take another specific value of x here. So we've got two values of x, x1 and x2. Which one is bigger, x1 or x2?
In terms of y value?
Nope, in terms of x values. X value is x1.
X2
x2 is bigger than x1 because it's further along the x-axis. Now we can take a look at the corresponding values of the function. So we can have f at x2 and f at x1. So these are our y values here. So which y value is bigger? Well, you can see that because f at x2 is higher up the y-axis than f at x1, the value f at x2 is going to be greater than f at x1. And this is what we mean mathematically when we say that a function is increasing. It means that if our function is increasing when the value of the function at x2 is greater than the function at x1 for x2 is greater than x1. So as we move to larger x values, the y values increase, is basically what this is saying. And it's going to be decreasing, increasing when this, and is decreasing when the converse is true. So when f at x2 is less than f at x1 for, again, x2 greater than x1. So as we go to larger x values, our y values, instead of increasing, decrease. Now, in calculus, we want to take a look at, we want to find the intervals where this function is increasing or decreasing, and we want to use it using, we want to do this using the derivative that we've been looking at here. So if I look at a point where, let's look at this interval BC where this function is increasing, and I draw the slope of the tangent here, the slope of the tangent here is clearly positive. Okay. So I'll just say positive here. And if I go to this interval where it is decreasing, and I draw my tangent here, the slope of my tangent is negative. Same thing over here between A and B. Okay. So intervals where my function is increasing, the slope of the tangent is positive. Intervals where my function is decreasing, the slope of the tangent is negative. So we can just summarize that down here as well. We can say that if f primed at x is greater than 0, okay, then f of x is increasing. If f primed at x is less than 0, then f at x is decreasing. Okay. So we can determine where a function is increasing or decreasing by looking at the sign of our derivative over the domain of this function. So let's just take a look at an example here of how we can do that. Here we've got a function, y equals x cubed plus 6x squared plus 9x plus 2, and we want to determine the intervals where this function is increasing and decreasing. Now, if we just go back a second here, what happens at these points where it goes from decreasing to increasing, and then from increasing to decreasing? These are the points B and C that we're looking at. What do we notice is happening at points B and C, Richard? Yeah, our tangent here is 0, okay? So if we want to find the intervals of increase and decrease, we first want to find these points where the tangent is going to be 0. So we actually so let's go back to our example here. Okay, we got our function here. The first thing we want to find is, let's just say first, find where, I'll just do y primed equals 0, okay, because that is going to divide up our intervals to define the intervals. So we can take the derivative of our function here. We're going to get 3x squared plus 12x plus 9. Set this equal to 0, and we want to solve this thing for x. So let's start factoring. We'll factor out the 3 to get x squared plus 4x plus 3. And then we'll factor this expression that we have in brackets as a trinomial. That's going to be x plus 1, x plus 3 equals 0. So the two numbers here that are going to help us divide up our intervals are going to be our solutions here, x equals -1 and x equals -3. So what we want to do is we want to check the sign of our derivative in each of these intervals. These intervals defined by x equals -1 and x equals -3. So we're going to have an interval from -infinity to -1, from -1, oh, sorry, I got to do these in the proper order, right? -3 is smaller than -1, so it's going to go from -infinity to -3, from -3 to -1, and then from -1 up to positive infinity. Okay, these three intervals cover the entire domain of the function here, from -infinity to positive infinity. And we want to check the sign of our derivative. Well, let's see. Our derivative, we've already factored it to 3, x plus 1, and x plus 3. So we want to check the sign of each of these terms in each of these intervals. And by doing that, we can figure out what the sign is of our entire derivative. So the first one's the hardest one. What's the sign of 3 going to be as we go through each of these intervals?
Negative, positive, or sorry, positive, wait, what?
Just the constant.
Oh, I'm sorry.
Yeah.
I'm just going down my chart.
Okay. So good. So the 3 is going to be positive no matter what happens. Okay? The x plus 1 is going to be, let's see, what? -2 negative, and positive. Okay? And the x plus 3 is going to be negative, positive, positive. Okay? I always do them going across because I know that each term should, if it changes sign, it should only change sign once in each row going across. So it goes negative, negative, it can change to positive. Once this one, the x plus 3 changes from negative to positive, I know it's not going to change back to negative again. So we can sum all this stuff up and get the sign of our derivative here. So this is going to be positive, negative, and positive. So what does this tell us? Well, let's see. If our slope here is positive, this thing is looking like this. If it's negative, our tangent is looking like this. If it's positive, our tangent is looking like this. So what can we say about our function here? Well, f of x is increasing. Well, it's obviously increasing. I should add a little row here. F of x is increasing here, decreasing here, and increasing over here. So is f of x, I'll spell is right, is increasing from, where is it increasing? Negative infinity to negative 3, and negative 1 to positive infinity, just using the interval notation, and is decreasing from negative 3 to negative 1. Okay. So we just finished by summing up those intervals there.